This afternoon I'm going to talk about our new pavement management and the mapping capabilities. So I'm going to start by giving some background about the history of our pavement management system. Then I'm going to talk about our new pavement management system, both of them as it relates to mapping. Pavement management system in TXDOT was developed in 1990 and in response to a federal requirement that every state needs to have a pavement management system by 1993. At that time, TXDOT, our maintenance division, had a system in place that was called the Pavement Evaluation System, PES. And so the PES was kind of expanded and modified into our pavement management system. For PES, we used to collect data on every 2 miles. We modified to half a mile. We used to collect 1/3 of the system. We kind of moved, some districts were doing 50% and some other moved to 100%. Then later on, everybody moved to 100% data collection. MapZapper, you probably heard the term MapZapper. Stuart today, when he was mentioning the TXDOT nomination, he said that PA is replacing several applications, and one of them is MapZapper. MapZapper was an application that was developed in-house by one of TXDOT employees. It's basically an Access database. So the data from the mainframe was downloaded into the Access database, and that Access database interfaces with ArcGIS. So it was relatively very user-friendly, and you select whatever you want, the district, the county, the year, and whatever attributes that you want to map, and you click, and you get the map. And and the district users really liked it and felt comfortable with it. And the person who developed it over the years made several upgrades. When PMIS was developed in 1993, the number one requirement from the user was to be able to display data on maps. And I'll give a simple example. If I want to know the condition of my roads in one of the counties, say Travis County here in Austin, if I want, then I will print a report, and this report will be probably a few hundred pages. That by the time I look at the condition in one road, by the time I go to the half of the pile, I forgot what I looked at the beginning. But you get this all information in one page by map. And a lot of people are visual, connect more with visual. So PMIS had 2 stages. Stage 1 was to meet the federal requirement. Stage 2 was to develop the mapping. And guess what? They canceled the stage 2 on the mainframe. That's why we had to do the MapZapper. And since the original system was on the mainframe, most of the users, what they only used was MapZapper. What they only knew was MapZapper. What they only used was MapZapper, because they were able to create maps and they were able also to run reports. So when TXDOT started the discussions with AgileAssets about using pavement analyst, part of the discussion was the emphasis that we need a good GIS system included in pavement analyst that will replace MapZapper. The districts are used to the mapping capabilities. The districts like using maps, and we need to have a very good mapping functionality inside Pavement Analyst. And in the user requirement, we had kind of a big document for the GIS user requirement part of our RFP, and these are kind of some of what we wanted. We wanted to be able to map the data by year. You know, you can go for any fiscal year and be able to map the data. You can map the data for a district, one district, two districts, or by county, or by maintenance section, more than one county. And also you can map it by highway system, so you can filter where you're just mapping for a specific highway. And we wanted to have the map as an output. Hopefully in the future we'll have the map as an input also. One of the features that we requested is a layout maker, where the user, when they click on a button, they get the layout already done with the frame, with the arrows, and with the legends and everything. We wanted the mapping capability so that the user doesn't need to have advanced GIS skills, kind of bulletproof. Anyone with kind of no GIS skills, you know, can run the maps. It can, you know, we want it to be intuitive enough that with just simple steps, then boom, you get your map with the layout maker. And the map can be exportable as a PDF. We wanted also to be able to query kind of the maps. So if you want to map condition scores or scores within a certain range, or if you want to map scores with kind of certain traffic limits, that we have this capability. Our system also interfaces with our crash record system. So we wanted also to have the capability to be able to map skid scores over our crash records, so that the district user can use this information. You know, TXDOT, we have a program called the Wet Surface Crash Reduction Program. And part of it that we look at areas with high accident rates, and we look at our skid scores, and we look at geometry, drainage, etc. So we wanted to have the ability to kind of map, you know, if we see an area with kind of a lot of accidents and low skid numbers, we usually have, you know, an immediate action to address these locations. And, you know, some of you may have seen our presentation yesterday on the 4-year plans. You know, we wanted to be able to map the projects on top of what, you know, the condition scores, on top of traffic data, so that kind of give us some helpful information. You know, we don't want to be spending kind of, you know, the district selected a project on an area that doesn't have any traffic, etc. Although they can do what they want anyway. We also wanted to be able to kind of have the capabilities of kind of changing map symbology, changing thickness of lines, changing colors, and, you know, fortunately, all these functionalities were included in the version that was delivered to TXDOT. You know, the AgileAssets team worked very hard to meet all of our requirements in a very tight time frame. There are still things that need to be done that will come in the near future. I think, I don't know if we can open it for questions now or after Juliana finishes. Does anyone have any questions for me? Yes. Here's one.
I don't really want it, but Fine. How do you do the data collection on road condition measurement across 80,000 centerline miles, and how long does that take? So how out of date is it when you finish it?
We collect 100% of road beds. What I mean by road bed, like for example, for divided highways, we collect one lane in each direction. For undivided highway, we only collect one lane. That comes up to about 90,000 lane miles approximately. We normally start the data collection September 1st, and we are normally finished with data collection and storage end of February, beginning of March. So you can say about 6 months. This year, we're switching to a totally new process. So we're in the kind of middle of the procurement process for a statewide contract for automated pavement data collection. So don't they usually say private sector is more efficient than government? So I expect them to finish it earlier than what we did. Okay, thank you. Pass it to Juliana.
Let's see here. How do I get his to?
That's yours right there.
Yeah. Maybe just start slideshow. Voila.
Excuse me. Microphone. Where's that microphone at?
Maybe he has. Do you still have the microphone? Thank you. Hi everyone, how are you? I'm Juliana Binfield and I'm a GIS consultant with AgileAssets. So I thought I'd kind of break the ice with a joke. So a man walks into a bar and he walks in with a chunk of asphalt underneath his arm. And the man turns to the bartender and says, "I'll have a beer and I'll take one for the road." Okay, so I'm doing this presentation in conjunction with TXDOT on how our mapping capabilities was integrated with TXDOT. And let me go to the next slide. So why is mapping assets important? So mapping assets is important because because maps tell us a story. Mapping our assets tells us a story about the geospatial view of our data in relation and conjunction to each other. Mapping assets and collection data helps users make better informed decisions. Am I too loud? I'm sorry. So today we're going to be going over the TXDOT functional specific requirements, GIS Explorer, our proof of concept, and then into the introduction of the GIS Explorer. And then we're also going to look into mapping TXDOT assets, and then also ending with the future of our GIS capabilities. So TXDOT needed something to replace MapZapper. So MapZapper, like Magdi said, was an application that was an access application, and it kind of, you put in a few filters and then it spits out a map using ArcGIS. So they needed something to replace that, something that was faster. So the performance needed to exceed that of the legacy system. We also, TXDOT required us to create something for printing maps. And then also the visualization of assets by administrative boundaries and routes. And they also wanted to be able to select fiscal year. Some other requirements were there needed to be some selection tools, an attributes window, the ability to create map reports, filter capabilities, and the ability to pull live data from PMS, and also to create static map reports that users can open using data. Oh, I'm sorry.
Oh, because see, look, it's showing a different one up here.
Can I just use the arrow?
Is it just locked up or something? Try clicking like the presenter view and
Right here?
no, this one right here. Yeah, click that. And then like unclick it. What's it doing?
IT? Anybody?
It's showing the right slide on the screen, guys. Oh, look, there's two open. I bet this is what's happening. That's not what's on the screen either.
That's Magni's.
Oh, there's tons of these open.
The other one?
This is the one that we actually want.
Yes. Yes. And we also wanted to be able to have, or TXDOT wanted a rich UI, UX that was easily accessible to the users. So for the GIS requirements, we needed the ability to map PMIS data by one or more fiscal year, district, county, maintenance section, and highway system. So our developers went to the drawing board and started developing a mapping application out of a TXDOT need. We decided to create a rich JS client for rendering maps that was client-centered and using REST services, using some of the JavaScript API, GeoServer, OGC standard services, using WMS or W3C standards. And it also used a combination of open source tools like GeoTools and Angular JavaScript. So out of that, we decided to make our GIS Explorer proof of concept. And so we created a partnership with ESRI, and we integrated our mapping application with ESRI's REST API. And this allowed the support of ESRI tools without adding extra layers to services. And it allowed the system to easily share maps and data using feature layers using ArcGIS Online. So it was a web-enabled platform, and we decided to consolidate all of the mapping windows into one intuitive web mapping control. So all of the mapping would be under one tab. And we also decided to visualize Oracle tables that have geometry. You can also visualize data using a Shapefile importer, and also ESRI Rest Services. We also implemented a GIS Explorer catalog where you can find all your layers and your map reports. And then the development and the deployment of the GIS Explorer would allow users to render and visualize assets, events, and LRS in a one-stop shop mapping application. And I think that's important because you have all of your data in one place. There's no need to go to any outside sources to look at your data. So I'm going to kind of go through a little introduction of the GIS Explorer. Kind of tell you about some of the icons. So this first icon is a new map. So if you have data in your table of contents, you can push this icon to basically clear out your map. This is to open up a map report. So if you already have a saved map report, you would use this icon to open. We also have a print icon. This is for printing. And also the save map report icon. So you put, your layers in your table of contents and you style them the way you'd like, and you can actually save that as a map report. This is the manage catalog icon. This is where you can find all your layers and your map reports. This is the area of interest filter, and this is where you can put administrative boundaries and then select data based on those. And then we also have a global route filter that you can use. And this is where you can visualize certain routes that you only want to see data for. And then down here we have a whole bunch of different base maps, ESRI base maps, and we can also customize base maps if you've published to ArcGIS Rest Services. And then this is a turn the table of contents on and off. You can kind of toggle it off and on so you can see more of the map. And then we also have courses at AgileAssets Learning Center for GIS Explorer. So if you'd like, you can take some of these courses and kind of just experiment with what it does. So to give a little more introduction to the GIS Explorer, there's 3 different ways that you can create a layer in your map. So the database table, that would be all of your Oracle database tables, Shapefile, and then also ESRI Rest Services. So with the ESRI Rest Services, you kind of type in your URL, and then it creates a layer. And the Shapefile, you load your shapefiles into a map folder, and then you can display shapefiles as a layer within the mapping. So this is the layer catalog, and so layers kind of look like a little map pin, and this is where all of those layers are stored in this catalog. There's a catalog tree with a place to make different folders, and this is where all those layers are stored. And then there's also a map catalog, and these are your map reports. So for GIS people out there, that's kind of like an MXD. And so you can basically put some layers in your table of contents and save that as a map report. So we also offer ESRI base maps and the ability to use custom base maps published to REST services. Now, TXDOT actually had its own base map, and so we incorporated that into the system. So with GIS Explorer, there are 5 different ways to filter and query. First being the area of interest filter, the map filter, the global route filter, the basic filter in the edit menu, and the where and the SQL clause in the creation of the layer. And I'll go into some of these. So there's also styles. There's a simple style where you can show a color for all of your lines as being, red. There's unique, where you choose an attribute and then you style that using different colors. And then also a range, where you can give a range value to an attribute, ranging from 1 to 10 and so on. Also the labels and legends, we have the ability to create legends and labels. And also TXDOT needed a way to offset their roadbeds. So we created an offset, so you can actually visualize roads a little better, especially when you're viewing large counties. And then also you can see your data with an attribute window. So this shows you features within your data. So styles allows users to show a layer by displaying data with simple, unique, and range values of attributes. It also allows users to change colors, style of the lines, points, and polygons. So this is my layer, and I go to the layer in the table of contents and click on the icon, the 3-dot icon, and then I edit the layer. And then, you know, I have a bunch of different attributes here, and let's say I want to change the color. So I pick color, and then I get a color ramp, and you can use qualitative, divergent, and sequential. And then you can also change the thickness of the lines and points, and as well as the style of the data. So, you know, you could use dotted lines or solid line or triangles. And then also you can click here to edit the color of your data. And you can click on the RGB selector. So certain states have certain RGB colors that they have to use. And so you enter the RGB value, and then you can actually use that color. So now getting into the area of interest, this allows users to select geographic boundaries or extents of DOT managed territories by using the AOI polygons, using a clipping or a cropping or masking effect to render the data of the base map. We also have a global route filter. This allows users to select only routes of interest by selecting names of routes using a clipping effect. And so here you can find it at the top right of your map. And this is the area of interest. And this is the crop button. And this is where your global route filter is. So with your map filter, this is a tool for selecting data for like effective year or fiscal year. And what the map filter does is it cascades down through all your layers within your table of contents and applies that filter. You click on map filter, and you can see that it's only applied to layers that actually have that column. If it does not, it shows up with a little orange icon. And so then you pick your effective year. We also have an attribute window, which many clients find very useful. You can see all of your data associated with that segment. So I can see here, you know, the ADT, the route name, it's a AG roadbed, and different information about that feature. So now we're going to talk about mapping TXDOT assets. So I'm going to open a map. So this is a map report. And I want to look at condition score classes. So when I open the map, I already have layers that are in here in my table of contents. And so I can see a map with all the different styles that I had chosen, and a map filter that I had applied. And so when users at TXDOT open up these saved map reports, you know, it's very user friendly because all they have to do is just open the map report. Then the users would select their area of interest. So I'd select a district name. And then I'm going to choose Austin, the Austin district, 14. And so then I would click on the crop button, and that would crop my data to the Austin district. So you can see it has a kind of a clipping effect where it only shows the boundary for that district. And then let's say I want to put in a global filter using a route name. I'm going to use IH35, the left roadbed, and IH35, the right roadbed. And so I can use the in operator, so I can choose, more than one route. And so then apply that, and now all I can see is IH35 and the data associated with that. So then let's say I want to apply a map filter now. So a map filter, remember, that cascades down through all the table of contents. And so any layer that is in your table of contents that has that field, this filter would get applied to that. So I'm going to choose effective year. It's already set at 2016, but let's say I want to see data for 2014. So I'm going to select 2014. And so now you can see the kind of green area, which is good, has kind of shifted up to the northern part of the district. And then so for printing, I click on the print icon, and then it takes you to this print layout screen. And it actually has a description, it'll come with the legend, and also you can use your image size scroll to get the map centered, and also the plus and minus at the very top right hand corner of the screen. The printing templates are created using Jasper and can be customized to fit client specifications. It comes in a .pdf or a .ping and appears in your downloads folder. So if I printed this map I just created, then this is kind of the template that printing would print out. We also have the option to select many different counties. So here I selected a whole bunch of counties, Comal, Hayes, and Travis, and Bear. And so now you can see data for multiple counties. And this is a landscape printing. And then also, let's say I want to zoom into a specific area. We call this area the Y here in Austin. And then I also changed the base map. So this would be another kind of print layout that you could do. The future of GIS capabilities with AgileAssets is we're currently designing that for the next version of GIS Explorer, which will include integrating ArcGIS server, and it will allow publishing of feature services, editing features on the map, and the ability to actually move locations, update attributes, and delete locations, and other capabilities. Thank you.
Are there any questions for Juliana or
Are there any videos available that would tell me more about the GIS features?
There are. They're at the Agile Assets Learning Center, and you can find that on our website.
Fascinating. Thank you.
Thank you, Margaret. Any other questions?
You mentioned in importing shape files. Does that mean that any feature class you wanted to import would have to be saved as a shapefile?
So a shapefile, yeah, it would be in the format of a shapefile to begin with, and then you put that in your map folder, and then you'd be able to create data in our system using that shapefile.
Anyone else? Still got a few minutes. Come on. All right, let's give it up for Magdi and Juliana.
Thank you.